Okay, Trig, this is part A of the semester final review. There are 40 questions of this review. The second half of it, I think the problems are a little bit longer or take a little bit longer. So I guess if you take 40 and divide by 3, that's going to be less than 15, but I think I would like to get through problem 15 in this first video at least, maybe even 16, just to do the first whole page. Just because I know that the second half of the problems are going to be a little bit longer, so just to kind of even this out. So the first 5 questions on here aren't designated to a certain chapter. They might be from chapter 5, but this is just kind of a good review, and then we start into chapter 6, which is just intro to trig. So we'll just go that route, start at the beginning and work to the end, and that's how we'll do this. So number 1, simplify without using a calculator. We are trying to subtract these two radical functions or radical expressions, and we can only do that if we have the same base. So this is the square root of 3. This would need to also be the square root of 3 in order to be able to subtract them. So I can't subtract them as they are now. But what I can do is the square root of 48 can break down into some pieces. A number that I know that goes into 48 that I can take the perfect square root of is 4, but there is a larger number. I know that 16 goes into 48 3 times. Okay, there's that 3 that I want, right? So the square root of 16 times the square root of 3 would be 4 square roots of 3. So this guy actually is 4 square roots of 3. And now that both of them are square root of 3, now I can add them together. So 11 square roots of 3 minus 4 square roots of 3 would be 7 square roots of 3. You don't subtract the 3's, you just subtract the numbers out in front. Okay, so that's what he looks like. This one, simplify. The first thing that we're going to do is get rid of this 2. So we need to distribute the 2 for all of those pieces. Okay, a lot of people forget to take this number in front and square it. So they forget to distribute the 2 for the number. So this should actually be 2 squared. X is to the 3rd power and then to the 2nd power. So then now I have to decide, am I adding or am I multiplying? Okay, you multiply. Or let's just look at the 2 scenarios. X squared times x cubed and x squared cubed. Okay, this is the scenario that I always deal with. In this first one, you're going to add. In the second one, you're going to multiply. So when they're stair-stepped like this, which is kind of in a sense what this one is doing, right? We have 3 and 2. You are going to multiply those together. So I always think back to this scenario. This guy will be x to the 6th power. Then we will have y to the negative 6th power on the top. On the bottom, nothing changes, so I'm just going to rewrite him. Okay. All right, then let's simplify a little bit further. So I have, this guy's 4. Okay, but then I can take and reduce the 4 and the 6. If I divide everything by 2, that will be 2 and 3. Okay, so I'm going to have a 2 on the top and a 3 on the bottom. All right, so my numbers are taken care of. Now the x's, okay, there's 6 on the top and negative 3 on the bottom. Okay, if I want to make that a positive 3, I can move him to the top. So he will become x to the 3rd power, and x to the 6th and an x to the 3rd is going to be x to the 9th. I add those together, okay? Now same thing with the y's. When I have y to the negative 6th power, I'm going to move him to the bottom to make him y to the positive 6th power. And then I combine these two, which will make y to the 11th power, and that's what he will look like, okay? Number 3, how long will it take to double an investment of $300 at 5% interest, which is compounded continuously? Okay, continuous compounding is that PERT equation that we had. Okay, so A equals PE to the RT power, where E is that 2.71828, blah, 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 that number that you have in your calculator. 300 is going to be my P value. That's what I'm starting with, my principal value. E is just E. The interest rate is 5 or 5% or 0.05. And it says how long. That tells me what I'm solving for. I am solving for t because t represents how long. T is time. Okay. Then what do I put in for a? Because if I'm solving for t, I need to have something to put in for a. Well, that's where this doubling part comes into play. If I'm starting with an investment of 300 and I want it to double, then that means my ending value has to be 600. Okay. So we're solving for this t up here. Okay. The first thing that I'm going to do to unwind this equation is divide by the 300. Okay. Divide by 300. And this will be 2 because we're doubling. Okay. e to the 0.05t. Now, if I have an e and I want to get rid of it, the thing that gets rid of e is ln, natural log, because ln and e are inverses of each other. Okay, so now I have ln of 2 equals 0.05t. Okay, and then if I just want to get t by itself, I can divide by 0.05 and then just do that in my calculator. So I've got a dumb calculator. Let's see if we can just get this to come out. ln of 2, make sure you close your parentheses, divided by 0.05. And that guy is 13.9, we'll say, is what t is. Okay, and that's probably going to be represented in years because compound interest is represented in years. So 13.9 years is how long it will take to double that investment. Okay, all right, number 4. Log of 4x equals 2. They want us to solve for x here. Okay, and the thing that I'm going to start out by doing is put a base of 10 in there, because if there's no base there, the base of that log is 10. And then a lot of times if you're trying to solve a log and you don't know what to do, let's switch him to an exponential function. Okay, so when I switch him to an exponential function, the 10 is going to stay, the base is going to stay, but the two other numbers switch. So this says 10 to the second power equals 4x. Right? Well, 10 to the second power is just 100. So now I just have 100 equals 4x, and then divide by 4, which you don't even need a calculator for, or you shouldn't anyway. 100 divided by 4 is 25, and there is what x is. Okay. Now, number 5, they want us to write that as a single log. So I have this piece right here and this piece right here, and subtraction in the middle. Okay, when I have subtraction in log world, that means divide. Okay, so I'm going to be dividing. But I have to get rid of this 2 first, okay? So to get rid of that 2, the only place for that 2 to go is back up here to the x minus 3. Okay, this would become x minus 3 squared. Okay, that 2 can go forward and backward however he wants, as long as there's a log there or an ln there, okay? So now I have ln of x minus 3 squared minus ln of 4x. I want to put them as one single ln, okay? And I'm going to end up dividing. So I'm going to write out a division, and the thing that's going to go on the top is the thing that comes before this subtraction symbol. So x minus 3 squared is going to go on top, and I'm dividing by 4x on the bottom, and this is what he will look like. Okay? All right, so just kind of a review that has some logs and stuff in there, and just some mixed review. Now we're going to get into some trig stuff. So switching this guy to degrees, okay? The thing to switch from degrees to radians and radians to degrees is either pi over 180 or 180 over pi, okay? So we've got to decide which one we're going to use. Since the pi is on top here, I want the pi to be on bottom when I multiply, so I'm going to use 180 over pi, okay? So that way the pi's will cancel out, and then I reduce anything else I can, so I know that 2 and 180 will reduce. If I divide both of them by 2, 2 divided by 2 is 1, this guy will become 90, so I just have 5 times 90. 5 times 9 is 45, so this guy will be 450 degrees. Okay. Number 7, given the angle measure represented by 2 rotations clockwise. Okay, so we always kind of start out here in standard position, and if I rotate around clockwise, as the clock goes, that means I'm doing this, and I'm doing that twice. So I end up right back over here. Okay, so how many degrees will that be if I'm going clockwise? Okay. Now, clockwise is kind of backwards from the way that we think of angles. When you're going positive, the positive direction, you go this direction. So counterclockwise actually represents a positive direction, okay? So this one is going to be a negative amount, okay? And if we're doing 2 rotations, one rotation is 360 degrees, 2 rotations will be 720 degrees, okay? Because 360 times 2 is going to be 720, okay? That is what it is in degrees, okay? Now, in radians, if they wanted the answer in radians, 1 rotation in radians is 2 pi, 2 rotations in radians is 4 pi. And it's still going to be negative because we're going clockwise. So this is radians, this is degrees, okay? That's what he will look like, all right? Number 8, identify all angles that are coterminal with 11 degrees, okay? Coterminal means that they're in the same spot. So 11 degrees would be just like right here, not very, it would even be smaller than that. But if I just draw any smaller than that, he might look like the same line. Okay, so there he is. If I rotate around one more time, we notice that he lands in exactly the same spot. So like 11 degrees, if I would add 360 to that, would be 371. That's going to be coterminal with 11 degrees, okay? But I want to identify all angles, okay? So what I would say is that I can take 11 degrees and I can add or subtract 360n, okay? We've written stuff like that before where we've done like plus 2 pi n or plus or minus blah, 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 right? Sometimes we'll just write it as plus 360n. That's fine. If we just say that n can be a negative number, then that kind of does the minus part for me. But this is representing all, okay? This tells me all angles, okay? And then they want us to find one positive one, which we've already done, 371, and one negative one, okay? So if I want to find the negative one, what I could do is take 11 and subtract 360, okay? And that's going to give me like 349, I think, negative 349 degrees, okay? That's what he will be, okay? So positive, negative, this is all of them, right? Last one on that page, find the measure of a reference angle for 227. Okay, so let's map out where 227 lives. Okay, here is 0, here is 90, here is 180, here is 270. Okay, we're in degrees. All right, 227 is going to live somewhere here in between 180 and 270. So this would be 227. But my reference angle is, if I make a triangle out of this, and remember that we always connect it back to the x-axis, we don't ever make hourglasses, we always make bow ties. Reference angle would be just this guy, okay? I want to know what that angle is. So I know that from here all the way around to here is 180 degrees, but then what would the rest of the way be, okay? 227, if I subtract 180, that will give me this little reference angle, which will be like 47 degrees, I think. This little reference angle right there is 47, okay? All right, let's go to the next page. Okay. Again, this is just intro to trig, so this stuff might seem pretty easy to you, and that's great. That's what it should be. Find the values of sine, cosine, and tangent for angle A. So I want sine of A, cosine of A, and tangent of A, okay? And they want just the fractions for each one, okay? So angle A is down over here. This is a right triangle, okay? That's how I know that I can use SOHCAHTOA. If he wasn't a right triangle, I would have to use like the law of sines or the law of cosines, which I think we'll end up doing on this sheet maybe somewhere. Not on this page though. So SOHCAHTOA will work, except I don't have my third side right here. Okay, 60, 80, and then I don't know what this guy is. Okay, now some of you guys might notice that this is a 3, 4, 5 right triangle. Okay, it's just multiplied by 20. So 3 times 20 is 60. 4 times 20 is 80. 5 times 20 is 100. Okay, so that's what that third side is. This is just a 3, 4, 5 that's enlarged, right? If you didn't already know that and that wasn't already like neon to you, like flashing signs to you, you can go ahead and do the Pythagorean theorem and you can find out that that was 100, okay? So what I'm going to do here is actually, even though we know that that's 100, I'm going to cross off this 60, 80, and 100, and we're actually going to reduce him down to a 3, 4, 5. Because when we do sine of A, he's going to end up being opposite of our hypotenuse. Okay, sine is opposite of our hypotenuse. Opposite will be 60 over 100. Well, 60 over 100 is just going to reduce back to 3 over 5. Okay, so I'm going to cross those bigger numbers out and just use the smaller numbers because then he will already be reduced for me. Okay, so cosine of A is adjacent over hypotenuse. The side that's adjacent is 4. The hypotenuse side is 5, so this guy will be 4/5. Okay, tangent of A is opposite over adjacent. So just, I'm going to write 3 over 4. There is what he is. Okay, so 3/4 is what that guy is. All right, so you can cross him out and just use the reduced ones. That way you don't have to reduce 3 times over here. You can just reduce it once on the triangle. Okay. All right, so we have another 3, 4 thing going on here. Find the value of all 6 trig functions for angle theta if 3, 4 is on its terminal side. So 1, 2, 3, 1, 2, 3, 4. He is this dot right here. Okay, so I have a 3, 4, and 5 is the hypotenuse side. That's what I kind of make a triangle out of him after I connect that dot back to the origin, and I need to find sine We'll call this angle in here theta. Cosine of theta, tangent of theta. And then sine goes with cosecant. Then we have secant and cotangent. So we've got each one of those 6 that we have going on here, okay? So we can use SOHCAHTOA again because we have a right triangle. Sine of this angle is opposite over hypotenuse. So opposite over hypotenuse is going to be 4/5, okay? And I'm going to go ahead and do cosecant at the same time, which is 5/4, okay? You just flip him around. Cosine is adjacent over hypotenuse, so that would be 3/5 and 5/3. That's what both of those guys are. And then tangent is opposite over adjacent, so 4/3 or 3/4 for cotangent, okay? So not too bad, pretty easy now. Number 12, find the values of the remaining 5 trig functions given that tangent of theta is -1. We're in quadrant 4, okay? All right, here's what I'm going to do. I'm going to use my unit circle. I have him kind of handy, so you might want to grab him. And I see that if we're in quadrant 4, and I want tangent to be -1, okay? That's where he is. He is at 315 degrees, which is actually this spot right here, okay? So this guy is the one that I'm looking at, okay? So I want to find the values of the remaining 5 trig functions. If he is over here in the 4th quadrant, this point is represented, I'm just going to write this down, the square root of 2/2, comma, negative square root of 2/2. Square root of 2/2, comma, negative square root of 2/2. That's the coordinates of that point. So I'm going to write him like this. Just kind of draw what he looks like so I don't have to keep flipping back and forth. Okay. Then they want the remaining 5 trig functions. So I'm going to do tangent. Let's do this. Let's do sine theta, cosine theta. We'll write out all 6 of them just because it'll be easier. Okay. And then we have cosecant theta, secant theta, and cotangent theta. Okay, we've got all 6 of them, okay? All right, I already know that tangent is -1, okay? And cotangent is going to be the opposite of -1. So it would be like 1/-1, which is still going to be -1, so that's kind of nice, okay? And then sine and cosine I get from here, right? Okay. Cosine is going to be the x, sine is the y. So cosine is the square root of 2/2, and sine is negative square root of 2/2. Okay. Now for cosecant and secant, if I flip those, that's what I will get for each one of those. Okay. But if I flip this guy, this will be -2 over the square root of 2. Okay. Which means that I have a square root in the bottom, and I don't want that. Okay. So -2 over the square root of 2. If I rationalize that, I'm going to multiply by the square root of 2/2, okay, which, let's do this. What he will end up looking like is -2 square roots of 2 all over the square root of 2 times the square root of 2 is the square root of 4, or just 2, okay, which means that these 2 will cancel out. Oh my gosh, that was a lot. So cosecant is just going to be negative square root of 2. After I flip him and rationalize him, that's what he will look like, okay? Now cosine is just the square root of 2/2, which is kind of like negative square root of 2/2. His answer, after I flip him and rationalize him, will just be positive square root of 2, and that's what he will look like, okay? So that rationalizing part was kind of the tricky part, okay? All right, 13. If B is 13, so I'm going to cross him out and I'm going to put 13 here. A is 76 degrees. They want us to find angle A, okay? All right, I know I can use SOHCAHTOA because he is a right triangle. So I'm looking at this angle and I'm saying, okay, A and 13, what are those in relationship to 76? Well, A is going to be your opposite and 13 is going to be your adjacent side. Okay, so I need the trig function that uses opposite and adjacent, and that is tangent, okay? And I take tangent of 76, and it's going to be equal to opposite, which they call A, over adjacent, which is 13. Okay, then to get A by itself, I'm going to multiply the 13 to the other side, and then I just get my calculator out. 13 times tangent of 76, 13 tangent 76. Looks like that. And he is 52.1 is what A will be. 52.1. Okay, and that's the value of A. So you just wanted us to find A. We have found him. All right. 1415. Given a central angle of 40 degrees. All right, let's map this out here. We have a circle, and we have a central angle. I always start my angles in standard position. So we have a 40-degree angle. Okay, 90 degrees straight up and down. 40 is a little less than half of that, so I have a 40-degree angle here. 40 degrees. I'm going to draw what he looks like. Find the length of the arc. That would be this guy right here. We're trying to find that length if the radius is 15 inches. Okay, now, when we're doing arc length here, this is asking us for a piece of the circumference. That's what we're asking for. Piece of the entire circumference. Okay, that's what they're asking for. So let's go ahead and find what the entire circumference is. Whole circumference is 2 times pi times the radius. Okay, so since the radius is 15, I can plug 15 in for that. So the whole circumference would be 30 pi. I just took the 2 times the 15. And then we're going to eventually end up multiplying that out, but for now we'll just leave them as 30 pi. Okay, now that 30 pi would be the distance all the way around the circle, but I only want this little piece of it. Okay, so the fraction of the circle that I want is only 40 degrees out of the entire 360 degrees. Okay, so when we do this, we take the whole circumference times the fraction that we want, right? The fraction of the circle that we want is only 40 degrees out of the 360. Okay, so I can knock off a 0 if I want to, and really 4 over 36 is 1/9. Okay, so if you want to just take it times 1/9, but whatever, that's fine. Let's go ahead and do, I'm going to do 30 pi in my calculator times 4 over 36, or you can do times 1/9. Okay, and that gives me, that distance is 10.5, let's see, what are we in? Round to the nearest tenth, so 1 decimal place, inches, 10.5 inches. So the entire circumference, but I'm only looking at that little piece of it, which is 10.5 inches. Okay, all right, number 15, find the area of one sector. Okay, here we go again. Here's my piece. I want a 70-degree angle. So 90 is straight up and down, so I want just a little bit larger, 70 degrees. But now I'm wanting the area of that, not just this arc length here. I'm wanting the entire area, so like shading this guy in. I want to know what this area is, okay? If the radius is 1.4 centimeters. Okay, so again, I'm going to take the whole area. And the area is pi radius squared. Okay, so, oh my goodness, pi radius squared, this would be pi times 1.4 squared. 1.4 squared, it should be like 1.96, yep. 1.96 pi is what he will be. That's the whole area. But I only want, so the whole area would be 1.96 if I would fill this entirely in. But I only want 70 degrees of it, okay? And that is 70 degrees out of an entire 360 degrees. Okay, so I'm going to take that 1.96 pi and multiply by 7 over 36. Or you can do 70 over 360, it doesn't matter. So 1.96 pi times 7 divided by 36. That's what he's going to look like. And I have 1.2. Now round to the nearest tenth, so 1 decimal place. 1.2, and he is in centimeters squared since he's area. Okay, so it's kind of the same procedure as what we did up here, except instead of doing circumference, we're doing area, and we're taking the entire area times the fraction, the whole times the fraction. Okay, and that will give us each one of those. Okay, let's go ahead and we'll save 16 for the next video. It's a short one, but we'll go ahead and save it for tomorrow. All right, so 15 questions done.